Hello guys, so welcome back to this channel. In this video I'll be doing some calculation question under Gauss law. Okay, in our previous class I taught you guys Gauss law. I gave you guys some important formula. I also stated the law for you guys. Okay, so in this class I'll be doing some important exam based question, okay, under Gauss law. Now let's start with the very first question. Very first question, they said the nucleus of an atom has a charge of 3e, okay, where E is the electronic charge. In this question, they are telling us to look at what they say. Find the flux through a sphere of radius 1 Armstrong. Okay, remember now take notes. An Armstrong is still descending as what? 10 raised to power minus 10. Okay, yes, it's still descending as 10 raised to power minus 10. Okay, yes. Now to solve this question, what are they telling us to look for? We are looking for what? Flaws. Okay, that we are looking for what? Flaws. Now this question is coming out from what? It's coming out from Gauss law. Remember Gauss law? Gauss law is telling us that flux is equals to what? Flux is equals to charge enclosed, okay? Is equals to charge enclosed, okay? Charge enclosed divided by what? Charge enclosed divided by what? Permittivity of free space, right? Yes. So this is basically Gauss law. Gauss law is telling us that the flux is equals to what? Is equals to charge enclosed divided by what? Divided by permittivity of free space, right? Yes. Now if you look at this question, that's telling us to look at what? They're telling us to look for flaws, right? Yes. Remember in our previous class, I will advise you if you have not gone through that class, I will advise you to go through it first before you come to this one, okay? Now in the previous class, I told you guys that flux is equals to what? Electric field times what? Times area, right? Yes. Now, if you don't want to stress yourself, let me just, in any exam, if you don't want to stress yourself, if they tell you to look for, flux, if you don't want to stress yourself at all, use Gauss law. Okay, because this question we can solve it using two ways. We can solve it using Gauss law, we can solve it using flux is equals to electric field times area. But we need to look for what? We need to look for our electric field, then we need to look for the area of the okay. Yeah, we look for the area, then we multiply it and get our flux, right? Yes. So if you don't want to waste your time, this is a trick. If you don't want to waste your time, use Gauss law. Gauss law is telling us that flux is equals to charge enclosed over what? Permittivity of free space. Remember, I told you guys, permittivity of free space, the value of permittivity of free space is what? Is 8.85 times 10 raised to power what? Minus 12, right? Yes. So know this value. It's very important. Know the value, okay? Yes. So if you want to solve flux, use Gauss law. Very easy. This is the simplest way. Just forget about this one. Use this one direct. Yes. Just put the charge. Look, where is the charge in this question? This is the charge in this question. Put the charge divided by what? By permittivity of free space. You get your flux. Easy. Okay? So that's just it. So what is our charge here is what? Is 3e. Then permittivity of free space is what? Permittivity of free space is 8.85 times 10 raised by what? Minus 12, right? Yes, remember, E, which is electronic charge, is what? Is 1.6 times 10 raised to power minus 19, right? Yes, electronic charge is 1.6 times 10 raised to power minus 19, right? Yes, so multiply it by 3, right? So 3 times E is what? 1.6 times 10 raised to power minus 19. Simple. Just take a calculator, do it, you get your flux instead of going through this long process. So that is just it. That is if they ask you to calculate for flux. In that way, if they ask you to calculate for flux in any question, just look for where the charge in that question. If they give you charge in that question, then you can easily get the flux without going through this long process. You put the charge there, divide by what? Permittivity of free space, get your answer. So let's do it. So 3 times 1.6 times 10 raised to the power minus 19, then divide by what? 8.85 times 10 raised to the power minus 12. So the flux is equals to what? Is 5. Our flux is 5.4 times 10 to the minus 8. Okay, so that's our answer. So the flux is equals to what? Is equals to 5.4. Okay, let me approximate 5.4 times 10 to the minus 8. So this is our answer, okay? Yes. Now let's use the long method, okay? We'll still get our answer, all right? Now remember, okay, I said find the flaws, right? Through a sphere of radius 1 Armstrong. Okay, so we are looking for flaws, right? Now, where is electric field? We are need to look for electric field first, then we look for the area, then multiply them, we get our answer. Now, remember, electric field is what from previous class. I will advise to go through our previous class, okay? Under Gauss law, electric field is equal to KQ, right? Divided by what? Arrow square, right? Yes, so put it here. KQ divided by what? Arrow square, then times area of a sphere. Now, what is the area of a sphere? The area of a sphere, please, this is very important. The area of a sphere is 4 pi arrow square. Okay, 4 pi arrow square. So times 4 pi arrow square. So if we do everything, we get our answer. Okay. So remember, we multiply with to get our answer. Remember, K is what? K is equals to 9 times 10 raised by 9, right? Yes. Go through our previous slide, you see everything. Okay, 9 times 10 is 9, right? Yes. So, yes, that's just it. So, let's continue. K is 9 times 10 raised by 9, then times the charge. The charge in this question is what? Is 3e, right? So, which is 3 times 1.6 times 10 raised by minus 19, right? Then divided by what? The radius. The radius is what? 1 Armstrong, right? 1 Armstrong is setting as what? 10 raised by minus 10, right? So it's 1 times 10 raised by minus 10, right? All square. Then times 4 times pi. Okay, now, before then, these two can cancel, right? Yes, these two can cancel. Yeah, I think they can cancel, right? Yes. Yeah, they can cancel. So, yeah, they can cancel. Okay. All right, so let's continue. They can cancel. So now I'm left with, I'm coming. I'm coming. Let me try something else. I'm coming. Okay, let's see. All over charge. No. All right, so okay, KQ square over. All right, so we are good to go. Okay, so these two can cancel, right? So we'll be left with, we can just clean this one. So we'll be left with 4 times pi, right? So let's multiply everything. Remember, pi is what? Is 3.142. So if we do everything, we still arrive at the same answer, right? Yeah, so let's do it. So let's just do it. So 9 times 10 raised to power 9, then times 3 times 1.6 times 10 raised to minus 19, then times 4 times 3.142, okay, times 3.142, okay. So our answer here is what? Is 5.4 times 10 raised to minus 8. So it's still the same thing, right? Yes. So what am I telling you guys? Just use, if you in an exam, just use the short method. You get your answer very fast. Okay. So can you either use this or can use Gauss law? So that's just it. Now let's move to the next question, question 2. Okay. So question 2. Question 2, they said a physicist surrounded a point charge of 5 microcoulomb with a sphere of radius 0.26 meters centered on the charge. Calculate the electric flux through the sphere. The same question again. Now, what are they telling us to look for? They are telling us to look for electric flux. Remember, electric flux is equals to EA, right? Yes. Now, if we use Gauss law, electric flux is equals to charge enclosed divided by what? Permittivity of free space, right? Yes. So you can use this first method, you still get your answer, but it's longer. But if we use the second method, this just use it. Let's use this very fast. In question, look for your charge. Where is your charge? 5 microcoulomb. Now, what macro is what? This U is known as macro, right? Macro is something as what? 10 raised to power minus 6, right? Yes. So it will now be 5 times 10 raised to minus 6, right? So 5 times 10 raised to minus 6. So our charge is what? 5 times 10 raised to minus 6, right? Yes, divided by permittivity of free space. Where is value of permittivity of free space is what? 8.85 times 10 raised to power minus 12. So if you divide everything, you get your answer. So let's do it. So now be 5 times 10 raised to power minus 6 divided by what? 8.85 times 10 raised to power minus 12. So if we do it, our answer is, I'm coming 1, 2, 3, 4, 5. So our answer is 5.6 times 10 raised to power 5. Okay. So our answer is, okay, we can say 5.65. Okay. 5.65 times 10 raised to power 5. Okay. So 1, 2, 3, 4, 5. Okay. So our answer is, the flaws is what? Our flaws is 5.65 times 10 raised by what? 5. Okay, so this is our answer. All right. So if you use the other method, if you use this one, you still get your answer, but it's very long process. Okay. So now let's move to the third question. All right. So let's move to the third question. So remember, like what I told you guys, if you have to calculate for flows in any question, if they give you charge in that question, just divide that charge with divide that charge by permittivity of free space, you get your flows. Okay, now let's move to what will be the magnitude of the electric field, of the electric field strength at a point 5 centimeter from an infinite line of charge of linear charge density 18 microcoulomb per centimeter, okay, situated in a medium of relative permittivity 1.5. Okay, so in this question, they are telling us to look for electric field. That's what they are telling us to look for. They are telling us to look for the electric field of an infinite line of charge. Okay, yes, so that's what they are telling us to look for. Now, in our previous class, I gave you guys a formula. I gave you guys a formula that relates electric field with I gave you guys a formula that relates electric field with infinite line of charge. I also gave you guys formula that relates electric field with surface charge density. Okay, yes. So now let me give you guys the formula. Now let me write down the formula. Okay. So now tell us to look for what the electric field of an infinite line of charge that is situated in a medium. Okay. Yes. Now let me give you guys the formula. And the formula is electric field is equals to this is linear charge density. Okay, this is linear charge density. So then electric field is equals to linear charge density divided by 2 permittivity of free space pi r. Okay, so this is the formula that relates linear charge density with electric field. Okay, yes. So if you have not watched our previous class video, I will advise you to go and watch them. Okay, yes. Now this formula, we use this formula is used when they ask us to calculate for electric field. They give us linear charge density. Look at it, linear charge density. Okay, they give us linear charge density. Now this formula is used when they give us linear charge density, right? And when the infinite line of charge is situated in a vacuum. I don't understand. It's situated in what? In a vacuum. Okay. So this formula is used when the when the infinite line of charge is situated in a vacuum. Okay, in a vacuum. Okay. But if you look at this question, they said the infinite line of charge is situated where? In a medium. Okay. Yes. So we are not going to use this formula to solve to solve. Okay. Yes. Now, because this formula is used when the infinite line of charge is situated in a vacuum. Okay. Yes. Now, remember in the previous class, I told you guys that relative permittivity is equals to permittivity of medium over what? Permittivity of free space. Now, the reason why this formula is used in vacuum is because of permittivity of free space, or you can say permittivity of vacuum. Okay, this symbol here is known as permittivity of free space or permittivity of vacuum. So this is where this entire formula, this is why we use this formula to calculate for what? For yeah, to use it in vacuum. Now, but remember, relative permittivity is equals to permittivity of medium over what? Permittivity of free space, right? Now, but if we replace this E naught with EM, permittivity of medium, we can use it to solve. Okay, yes. So this is the formula we're going to use to solve. All right, yes. Now if you look at the question very well, they give us linear charge density to be what? They give us linear charge density to be 18 microcoulomb per centimeter. Okay, they give us the distance, or you can say the radius. They give us distance to be what is distance to be 5 centimeter. Okay, 5 centimeter. Then okay, they gave us relative permittivity to what? To 1.5. Relative permittivity to what? 1.5. Okay. Then we all know E naught generally. We know E naught, right? to be 8.85 times 10 raised to the minus 12. Now, but they didn't give us they didn't give us permittivity of medium. They didn't give us that one. Okay, remember we're looking for electric field of an infinite line of charge situated in a medium. So they didn't give us EM, but they gave us indirectly. Okay, now remember, relative permittivity is equals to permittivity of medium over what? Permittivity of free space, right? Yes. Since they didn't give us this one directly, we are going to look for it indirectly. Okay, so but if you normally if you cross multiply, we find out that EM, which is permittivity of medium, is equals to ER times what? E naught, right? Yes. So since they didn't give us this one directly, we can make use of this. Because look at it. E permittivity of relative permittivity times permittivity of vacuum is equals to what? EM. So in place of EM, we can put ER times E naught, right? Yes. So in place of EM, we'll put what? ER times E naught. Then let's not forget pi arrow, right? Yes. So this is formula we're going to use. So this is formula we're going to use. So in a medium, right? So this formula we use in medium, right? Yes. ERO EM. I mean ERO E naught. Multiplying each other is still the same thing as what? Permittivity of medium, right? Yes. So this formula we are going to use to calculate for what? Electric field. Okay, so let's continue. Now, before we continue, if you look at this linear charge density, right? Yes, look at linear charge density. We need to is 18 microcoulomb per centimeter. So we need to convert this microcoulomb to just coulomb, then this centimeter to just meter. So what we're going to do is let's convert it. Now, 18 microcoulomb per cm is still something as what? 18 microcoulomb dividing 1 centimeter, right? Yes. See the same thing, right? Yes. Now don't forget that micro is something as well 10 raised by minus 6. Okay. So we want to convert this microcoulomb to just coulomb. Okay. Yes. So let's do it. 18 times micro is what? Is 10 raised by what? Minus 6. Then we add our coulomb. Then divide by 1. Now you see this centi. Now I want to convert this centimeter to just meter, right? Remember, centi which is C, or centi is something as well. 10 to what? Minus 2. Okay. Yes, it's still something as 10 to minus 2. So 1 times centi is what? 10 to minus 2, right? So 10 to minus 2, then our normal meter, right? So if you look at it, we are converted from a microcoulomb per centimeter to what? To just coulomb per what? To just coulomb per meter, right? So let's do it. Okay, let's simplify it further. So 18 divided 1 still give us 18 divided 1 still give us 18, right? If you look at it, 10 raised by minus 6 divided by 10 raised by minus 2. This one, if they cancel, we left with what? 10 raised by minus 4, right? Yes, 10 raised by minus 4 coulomb per meter. So therefore, our linear charge density is 18 times 10 raised by minus 4 coulomb per meter. Okay. Yes. Then what about our radius? Let's convert it or distance. Let's convert that centimeter to what? To meter. It's very easy. Remember, centi is what? Centi is what? 10 raised by minus 2. Right? So left and the meter. So we already converted it. Right? Yes. So R is what? Is 5 times 10 raised by what? Minus 2 meter. Okay. Yes. All right. So I think, yeah, that is all. Now let's impute everything into this formula. So let's continue. Looking for electric field, right? Okay, so let's continue. Linear charge density is what? Is 18 times 10 to the minus 4, right? Then divided by 2 times relative permittivity is what? 1.5, right? Then permittivity of vacuum or permittivity of free space is what? Is 8.85 times 10 raised by what? Minus 12. Then times pi is what? 3.142, right? Then times arrow is what? 5 times 10 raised by minus 2. So if we do everything, if we divide everything, we get the electric field. So it's very easy. And let's do it. So let's divide it. So 18 times 10 raised by minus 4, then divide by 2 times 1.5 times 8.85 times 10 raised by minus 12 then times 3.142, then times bracket open. Okay, then times 5 times 10 raised to power what minus 2. So if we do it, our electric field will be, I'm coming 1, 2, 3, 4, 5, 6, 7, 8. Wait, I'm coming 1, 2, 3, 4, 5, 6, 7, 8. So our answer will be 4.32 times 10 raised to power 8. Okay, so 4.32 times 10 raised to power 8. Well, unit for electric field is Newton per coulomb. Okay, so this is the answer. This is our electric field. Okay, yes. So that is just it. Now let's move to the last question. Okay, yeah. So we are going to go to our previous class. Okay, we are talking about linear charge density, surface charge density, volume charge density, then the relation with electric field. Okay, just go to our previous class under electric field as well as the theoretical part of Gauss law. Okay, so now let's move to the next question. Last question is which is question 4. Okay, so in question 4, they said they said a negative point charge 4.8 microcoulomb is surrounded by a sphere with a radius of 0.55 meter centered on the charge. Find the magnitude of the electric field and electric flux. They're telling us to look for two things. They're telling us to look for electric flux, then they're telling us to look for what electric field. Very easy. Okay. Now remember, to the guys, to look for electric flux easily, if they give you charge easily, use Gauss law. Gauss law is telling us that electric flux is equals to the charge enclosed, right? The charge enclosed divided by what? Divided by permittivity of free space, right? Yes, this is Gauss law, right? Yes, so you are looking for electric flux, right? So the charge enclosed, this is the charge. The charge this is just easy without looking for go and look for the area first, then multiply this, multiply that. You can just go straight you can just use this formula to get everything once. So the charge enclosed is 4.8 microcoulomb. So 4.8 microcoulomb. Micro is the same thing as what 10 raised to the power minus 6, right? Then we put our coulomb there, then divide by permittivity of free space. What is the formula? What is the value? Is what is 8.85 times 10 raised by 1 minus 12. So if we do it, divide them, get our electric flux. So let's do it. So 4.8 times 10 raised by minus 6, then divide by 8.85 times 10 raised to power minus 12. So if we do it, we get, I'm coming 1, 2, 3, 4, 5. We get, our answer will be, our electric flux will be 5.42 times 10 raised by what? 5. Okay, yes, that's 10 raised by 5. So these are our electric flux. All right, then worry about, remember that telling us to look for two things: electric flux and electric field. Now worry about our electric field. It's very easy. So if I've gotten our electric flux, we can easily use electric flux to get electric field. Yes, remember electric flux. What is the formula for electric flux? Electric flux is what is EA, right? Yes. So this is one formula for electric flux. Then this is another formula for electric flux. Charge and Gauss law, right? Charge enclosed divided by what? E naught. So this is another formula, right? Yes. So this is electric field times area. So okay, yeah. So we have already gotten our electric flux. We need to get our area. Then we use these two to get the electric field, which is very easy. Okay, now let's get our area. Okay, so let's get the area. We have already, our electric flux is what? The electric flux is 5.42 times 10 raised to power 5, right? Then equals to electric field, right? We don't know electric field, that's what we're looking for. I'm coming. Equals to electric field, then times area. Now the area of what? The area of what? The area of a sphere. So what is the area of a sphere? The area of a sphere is what is 4 pi r square. So times 4 pi r square. Okay, now our arrow is what? Our arrow in the question is 0.55, right? So 0.55. Then don't forget about the square or square, right? Yes, so let's divide both sides. One, we are looking for e, so we divide both sides by 4 pi bracket open 0.55 all square. Okay, divide both sides by this value, right? 4 pi bracket open 0.55 all square, right? So this one cancel this, so be left with e is equals to, okay, so So our E, which is electric field, will be equals to what? 5.42 times 10 raised to the power 5 divided by what? 4 pi bracket open 0.55 all square. Now 4 pi is what? Is 3.142, right? So 4 times 3.142, right? Yeah, so let's use our calculator to do it, to get our electric field. So it's very easy. All right, so with 5.42 times 10 raised to power 5, then divide by what? Divide by 4 times 3.142 bracket open 0.55 bracket close all square. Then so I want the electric field is, I'm coming 1 2 2 4 5. So the electric field is 1.43 times 10 raised to power 5 Newton per coulomb. So this is our electric field. Okay, so this is the end of um problems relating to calculation related to Gauss law. Okay, so in our next class, our next class will be electric electric potential. Okay.